Hello, you are welcome to today's lesson. We are going to continue from where we stopped in our calculation of indices. If you are just joining us for the first time, I want you to know that in this lesson, you are going to learn how to solve indices. And I have prepared different questions which I am going to use to explain how to solve any questions in indices. So let's begin. So we stop at question 6 in our calculations of indices 1. Today we are going to continue uh, from question 7. So we have the first question, which says solve the equation 9 raised to the power of 2x minus 3 divided by 3 raised to the power of x plus 3 equal to 1. So let's begin. I love to write this solution. When you look at this equation, we are going to cross multiply first. That is the first thing to do. So this is 1, so this is like over 1. So if you like, I made this over 1. So when we cross multiply, we should have 9 raised to the power of 2x minus 3 equal to 3x, 3 raised to the power of x plus 3. So this multiplied this. So we have cross multiply. And then now you need to look at the bases, the base here and the base here. So the lowest base here is 3, and then we have 9 here. So we are going to make this 9 to have the same base with this expression, which is going to be 3 raised to the power of 2 brackets 2x minus 3, and then we close this bracket, equal to 3 to the power of 1 if you want to put it that way. Okay. Still okay. Then we close the brackets, and then now we can this we take out this we cancel this, and this we also cancel this. So we are going to have 2 brackets 2x minus 3 close brackets equal to if you want, let's just put it there, plus this. Okay, so don't forget this, take care of this, so cancel out. So let's open the brackets, 2 times 2x, so we should have 4x minus 2 times 3, we should have 6, yes, equal to 1 times 1x, we have 1x, so we should have everything. 1 times 3 is 3, and then the next thing to do, the next step is to collect like terms. So here we have 4x, we put the same variable on the same side, x here comes here, and it's going to become minus x. Why am I trying to write plus? No, you are negative in this case. So minus the 1x equal to, this is minus 6. When it goes to this side, crossing this equal sign, it's going to become plus 6. And then, oh, my 6 is ugly. I don't like this 6. like it. So I'm going to write it 6 plus 3. So let's see what we have. So we should have 3x here, and then we have 9 here. So we are looking for x. We are going to divide both sides by 3. So which means we should have 3 equal to, sorry, x equal to 9 divided by 3. And then we should have our answer as what? 3. So our x is equal to 3. You can see, very simple. Okay, let's do the next one. Question 8 says, simplify 625 raised to the power of 3 over 8. That is the fractional index. So multiply by 5 raised to the power of 1 over 2. And then divided by 25. Divided by 25. So let's express this properly and then we solve the problem. So we have okay, I want to write solution. Okay, so we have 625 raised to the power of 3 divided by 8 multiplied by, what do you have here? 5 is raised to the power of half, then divided by 25. So we should have something like this. 25. Yeah. This is what we have here. Okay. Again, what you need to do here is to express that is to convert all the bases here to the same thing. So we have 625 as a base, 5 as a base, and 25 here. If you like, want to say here it is raised to the power of 1, okay? It doesn't matter. So we leave it as it is here. So here we have 5, which is the lowest base. So we are going to convert this into 5 to have the base of 5, and this also to have the base of 5. To do this, so 625 raised to the power, what is going to be that? Expressing it, the base as 5. So it is basically going to be 5 raised to the power of 4. Yes, brackets 3 over 8. Close the bracket, 8 ugly there. Multiply by 5 raised to the power of the half that we have. So it's already in base 5. Then divided by 5 squared. That is 5 raised to the power of what? 2. Yes, that is what we are going to have over there. Okay, so now this 4, we cancel this. So we should have 2 here. And then we are going to have 5 raised to the power of 3 over 2, and then multiply by 5 raised to the power of this here. I'm not repeating this. I should have just expressed it once to save space. Square. So here, according to the multiplication law of indices, which says that we should add the indices, that is the powers, provided that the bases are the same. If they have the same base, so we just add the power. So here we are going to just say 5, biggest big number, the base, so raised to the power of 3 over 2 plus 1/2. So we just pick one base, then divided by this 5/2. 5 raised to the power of 2 rather. Then, so when we add this, so we are going to have 5. They have the common denominator, so this is going to be 4/2. Yes. Divided by 5 raised to the power of 2. So this can cancel this. So we are going to have 5 raised to the power of 2 here. So basically we are having 5 to the power of raised to the power of 2 divided by 5 raised to the power of 2. So what do we have here? So the answer should just be what? 1. And if you like, if you want to take this, yes, it is 1. The answer is 1. If you want to take this up, it's going to be -2, and 2 minus 2 is 0. 5 raised to the power of 0 is still the same thing as 1. So if you want to do that, let me just show you this corner. Let me put it here for you. So if you want to say 5 raised to the power of 2, since this is below it, yes, this is below, so divided, so we take the power up since they are common base, so minus, according to the division law, minus, so we are going to have 5 raised to the power of 0, and in indices, I've covered that when in my video lesson about the loss of indices. So if anything raised to the power of 0 is just 1, so we still arrive at 1, so still the same thing. Okay, you can see it is very simple to calculate indices. Just follow the steps. Okay, let's now move to the next examples. Okay, so let me erase the screen. So we have our next example here. We have if 343, which is raised to the power of y plus 5, yeah, it is raised to the power of y plus 5, equal to 49 raised to the power of 2y, find y. We are going to find y. So in this problem, we are not finding x again because we have already found x, and x is now resting where x was kidnapped, and then luckily for us, we found him. Now it's resting well. So it is y's turn now. So we are looking for y in this problem. Okay, don't mind me, I'm just joking. So let's get down to business and find this missing y. So this expression, again, we are going to express in such a way that they are going to have common basis. Yes. So this is 300 and, excuse me, 43 raised to the power of, let me write it well, y plus 5. So this is how it is. And then it is equal to 49 raised to what power? To the power of 2y. So let's express them in such a way that they're going to have a common base. Yeah. So here, this is 49. So this is going to be 7 raised to the power of 3. Because 7 times 7 is 49 times another 7, that will give you this results. Yes. So raised power of 3, then brackets y plus 5. So we close the brackets, equal to 7 raised to the power of 2 here. Yes. Brackets 2y. Are you still doubting this? Why is this looking this way? No, I don't need this. I want to erase it. So that's, I want to confuse anyone. So what do we have here? Y, yeah, plus 5. Okay, so 7 times 7 is 49, and 7 times 49 is 343. So we have expressed them. So this cancel this cancel this again. So they are out. They both shoot each other. So we should have 3 raised to the sorry, not raised to any power. Okay. Equal to 2y. So let's open this bracket. 3 times y is 3y plus 3 times 5, 15, equal to 4y. 4y. Again, so we are just going to collect like terms here. So here we have 15 plus 15, so it's this, equal to 4y, and then this 3y will come and meet this guy here. And if you want to collect it, well, it's still the same thing, but let me do it the other way to make it more clearer, but it's still the same thing, whichever way you choose to do it. So let's say 3y is here, minus 4y equal to 15. Is it just 15? Minus 15. Yes, minus 15. So here we should have minus y. So let me put it here. Minus y. I think you can see that below. There's this space. So we have minus 1y equal to minus 15. So the minus will cancel each other. So this also cancel this. So we should have, therefore, our y that is missing is 15. Yes, hope. Just 15. Yeah. Okay. I hope you are learning something. Let's move to the last question. This question 10. Simplify 7 raised to the power of 1.5 decimal index. Multiply by 49 raised to the power of 1.75. That is another decimal index. So we are going to tackle these guys and solve the problem. So, okay, the instruction says leaving your answer in index form. Okay, we are going to do that. Thank you for the reminder. I want to use green color. So beautiful. So here, for us to solve this problem successfully, we need to convert the indices into fraction. So we convert this into fraction, and then we can now solve the problem. So let's see. 7 raised to the power of 1.5 is going to be 7 raised to the power of 15 divided by 10. So you just multiply each index by 10. So we convert to a fraction. And when we do that, we should be able to solve the problem. But if you don't do that, it's going to just give us problem. Did I just say multiplying by 10? No, not multiplying by 10. Uh, times 49. Okay, multiply by not 49 is there is given. So here we multiply this by 100. Yes, multiply this by 100, and when we do that, we should have 775 divided by 100. So this is going to be this. Yeah. Okay. Then the next step is to convert the base into the same thing. So we change. So since the lowest base is 7, and then here is 49, so we change this base to 7 too. So this is going to be 7 raised to the power. But before then, this can take out this. So let's divide this to the indices. Let's make the indices to have this lowest fraction. Let's take the indices to the lowest fraction. So 5 here is 3, and 5 here is 2. Yes. What can divide this to the lowest fraction? The equivalence fraction. Lowest fraction here. So 25 divided this, yes. 25 should divide this. So when 25 divides 175, what are we going to have? Can someone just whisper the answer into my ear? What are we going to have? Yes. What are we going to have? So we should have 7. Okay, 7. And then divide this by 25. So we are going to have 4. Yes, 4. So let's continue. So we have our index here is 3 over 2 times 49, which now has 7 over 4 as its index here. So let's now convert them to have similar base. So times 7 raised to the power of 2 is 49. So we should have 3 brackets 7 over 4. Don't forget this bracket. So these 2 can cancel this 4, and we should have 2 when that happens. So we have now we have 7 raised to the power of 2. Let's follow the steps, not rushing. Then 7 is raised to the power of 7 over 2. You can see. So the work is done now, because it is now very easy to find the final answer. So what we are going to do here, again, according to the multiplication law of indices, we are going to add the indices. Since the bases are just the same, they have common base, so it's 7, 7. So let's just pick one. So we have 3 over 2 plus 7 over 2. So the denominators are the same thing, so we are just going to add the numerator. So we should have 7 raised to the power of 10. Yes, 10 over 2. And then finally our answer should be, to cancel this, it's going to be 5. 7 is raised to the power of 5. And that's all. So we have solved the problem that looks complicated from the beginning. So it's just very simple. Once you can apply the laws of indices, so you are going to be able to solve any problem in indices. So far so we have solved 10 problems in indices, and these are questions enough for you to understand how to tackle any problem in indices. I hope you have learned something in this video. Thank you for taking your time to watch it. Please subscribe to my channel. Just click the subscription button. It is free so that you can get notification of my new video lessons. You can also share my video to help students who are struggling with mathematics, to also help those who are preparing for mathematics exam, be it at O level, A level, WAEC, NECO, JAM, or any IGCSE or any other mathematics exams. Okay, thank you once again. Goodbye.